Okay.
Okay, and we are live. Hi, everyone. Welcome. I've been off air for a while, so I'm excited to get back on and talk to you guys and do a new presentation with an awesome presenter. So my name is Laura Montoya. I'm with the AI and Deep Learning Enthusiasts and Excel AI, and we are bringing to you a new AI web series where we feature different and unique and diverse entrepreneurs and founders of different AI products. Just to show you how you can apply AI and deep learning in new and unique ways. So today we have Carlos Uranga, and he is an entrepreneur and investor, and he specializes in robotics. And today he's going to be sharing with us deep learning as a service is going to be his talk. And also, just a little information about our organization. Excel AI, we are a 501c3 nonprofit. And our mission is to shape the next generation of AI engineers and enthusiasts. So specifically, we are lowering the barriers to entry in engineering artificial intelligence with a focus on integrating AI and social impact through training, study sessions, and events, such as our Demystifying AI events and our online sessions as well. So let me go ahead and put Carlos online here for you. And Carlos, would you like to give a little more info about yourself?
Sure. Thank you, Laura. Well, I am a serial entrepreneur here in the Silicon Valley, and my background is in bioengineering. I consider myself a generalist, and one of the big things that I'm interested in here is making sense of all this big data that we're generating, in particular on the generation side of things. And yeah, I just want to talk a little bit about my experiences with what I call as what people are starting to call deep learning as a service, which I think is pretty interesting.
Great. And then do you want to do screen sharing?
Yeah, let me start this presentation here.
And also, just a reminder, feel free to post questions or comments in our chat thread. We are going to save most of the comments till the end of the session once he's done with his presentation. And it looks like Carlos might be having a little technical difficulty. Carlos, you still with us?
Hi there.
Okay, there we go. Perfect.
Sorry about that. Yeah, first Chrome died when I did a quick screen share. So let me try that again.
Okay, not a problem.
Here we go. Present other screen. Okay, let me see if that works this time. Can you see that now?
Yes, you can.
You see yourself, right?
Yes. Yeah. You want to do a full presentation?
Yeah. That's fine. Here we go. Let's try it this way. Okay, so does that look better?
Perfect, thank you.
Excellent. Okay, so So deep learning as a service, it's kind of one of those kind of cliched terms, as a service, but actually it seems very relevant to me personally, and hopefully just in discussing my journey in deciding for my startup, which is Lush Robotics. So I'm the CEO, co-founder of Lush Robotics, Inc. And I'll explain a little bit more what Lush Robotics does, but basically it's definitely a hardware-based company and looking to actually generate big data. And so one of the big things there and the challenges is that we have what we consider the true full stack development pipeline that we have to develop from the ground up. And as a startup, you have to, really obviously think lean operations and then think of how to leverage all the tools that you have available. Deep learning being one of them. So one of the main things that we wanted to discuss is if it's something that we want to bring in-house or something that maybe we want to outsource a little bit. So I think this is relevant for both startups and well-established companies alike. And so, yeah, just going to have a conversation. Hopefully you guys find it interesting. And I'll go from there. But so I also wanted to point out that we're also starting up this deep racing effort with 2 other people here in the South Bay. We're going to start racing robots. It starts with the little 1/16 remote control cars that are now becoming autonomous. So if you guys are interested, please shoot me an email. Right now we don't have much set up except for just shoot me an email at carlos@lushrobotics.com if you're interested also in joining us here in South Bay for some racing fun and a great learning experience. Oops, there we go. Okay, so here's a little roadmap for the talk. I try to keep it as simple as possible, but it is kind of a hodgepodge of a lot of stuff. So hopefully this little insert slide that I have here will help guide us along. So the main thing here I wanted to talk about is keeping up with what I call this craziness, the AI tech explosion. And then I'm going to talk about deep learning as a service, what it is, and where I think it's headed. Then a little bit about my background, and what I find useful is I'm coming from Singularity University. I was the director of the innovation lab there for a great experience. I was a mentor and teacher and kind of the digital fabrication guru, bringing in robotics and other what we call exponential tech, basically technologies that are leveraging the cell phone and other consumerized hardware to be able to solve grand challenges. And so we have, just a brief 3 slides or so of talking about technology in general and why we are seeing what we're seeing in both hardware and software innovation, and how to leverage it. So I think when you understand that, you can learn how to leverage these technologies wisely. So then, again, leveraging MLDL for your project or enterprise. I'm asking this question. I think everybody should ask this to themselves. Either you're a developer or leveraging it for yourself to find a job in machine learning or deep learning, or to bring in a core competency into your company. So all relevant discussion to this is just asking that question. Is it right for my enterprise to bring it in-house or to outsource? And then what does it take? Very basic, back of the envelope calculations of the money you need, the type of team you need is what we're going to discuss here. And then in conclusion, just summarizing everything here. So I'm going to start off with what I think is super interesting is just to see the trend of what's been happening in the last 5 or so years. In 2012 is really like the 2009 and 2012, right around there, they're all calling this kind of like the Big Bang of deep learning. And what do they refer to that is when they when 2 things came together: old concepts and neural networks, and then also the hardware was ready there to be used to be able to crunch these huge data sets. So we're going to talk a little bit about that hardware-software phenomenon that happened. But here is what you're seeing is in this graph. This is a really interesting article from MIT Tech Review. It's showing the publications going from 2012 all the way to 2016. And you can see like basically a little lag curve. And then what I think is, it's hard to tell from here, but looking forward beyond 2016, 2017, I still haven't pulled the publications. These are the number of publications that they're seeing come out in major journals, and we're talking Nature, Science, about deep learning in general. And I think Google made just a phenomenal effort to open source much of what we use today, and what I think Excel.ai has classes about is TensorFlow. Open sourcing that tool so that everybody can leverage their hardware and/or go into the cloud and start training these data sets and seeing these interesting patterns in their data. So starting to play with it. This right here is what I think is a hallmark of what crowdsource innovation is. Throwing these amazing technologies out into the crowd, you're starting to see people play with it. And I think that's what we're seeing in this explosion, right? So we're starting to, I purposely made a busy slide here because, I myself, I'm coming in from knowing my biology, my robotics, and all of a sudden I have to learn these new things to better build out all the way from the sensor all the way to the data processing pipeline. How am I going to deal with all this massive amounts of data, and what am I looking for really? So I call these machine learning cheat sheets. That and this one in particular, I find it kind of humorous. Is that a mostly complete chart of neural networks? Well, I mean, this is an interesting, I think, conveyance of all the multitude of methods that you can have to be able to properly find patterns in your data. And I've played around a little bit with these things, mostly with the the kind of the cookbook protocols out there to run my data through, because mostly image based at the moment. But then when I started thinking kind of outside of the box, it started getting really confusing really fast. And this is where you need that PhD in deep learning, maybe for some of these applications, if it's outside of that box. So I relied on my instincts there and just started to navigate through. And then what I'm seeing here is kind of a trend in other technologies. I've seen this before, is where you're starting to seeing like kind of an application explosion, where you see these kind of cookbook recipes come out. Then you start seeing these little languages pop out, machine learning languages, which might be super useful for a certain application. And then they're starting to coalesce into these cheat sheets, right? So you have input, output, universality. And then you start seeing, scripting and automation of these kind of small frameworks of processing data. But then what's going to happen, and this is what the talk is kind of all about, is that you have this full stack of machine learning DL frameworks that are starting to develop. So APIs and what I consider as deep learning as a service. So API meaning just a software solution to be able to just have a web interface. You upload all these massive amounts of data, and if it's facial recognition, you got it. Basically, Amazon Cloud and also Google Cloud have developed those particular technologies quite well, and there's a lot of tools available for that. So if your project is in that space or in that direction, then you got it made. I think you have enough out there to be able to just leverage what's out there, and then maybe just be an application scientist level, not a research scientist, for making this process, this whole pipeline for yourself. So then the deep learning as a service is now what I consider bringing in other expertise, in both in robotics and or data analytics, and now deep learning expertise to be able to forge a new path. And that's where I think things are headed, but we're not quite there yet. And that's why I wanted to discuss right now is what we have to decide, especially if you're a startup, where do you spend all your effort? And later, AI 2.0, sorry for all the cliche 2.0 stuff, but what I'm trying to describe here is software teaching software. So eventually that's kind of where, futurists, et cetera, are starting to postulate when we actually have like general AI and all these other things, which are a whole different discussion. But we'll touch on briefly just to see where this is all headed. But one interesting startup that I got involved with there at Singularity actually was Iris.ai. So this is a Singularity University company coming from the Global Solutions Program. And here, Anita and team, a Norwegian-Finnish combo here, they're actually trying to grab all the journal articles and make better science through digesting research papers. Now, I'm paraphrasing here. This is what I take away from their startup and what we discussed when they were kind of conceptualizing this whole thing. Well, I think they're just ahead of their time and definitely on an awesome path to helping people out, making sense of all science in general, but in particular, deep learning. Now, when you have all these research articles that I just described that Google is helping spawn out, well, how do we know what we need? And you know, the old method is to go do a quick Google search of what you think you need, and obviously that puts inherent bias in your search results, and that's kind of the frustration of anybody that's trying to kind of forge a new path. You don't really know what you don't know. And so once we have this kind of AI tool to be able to digest massive amounts of research articles that are happening out there, then we're going to have a much better time being able to build this for yourself or in-house. But what I find that you know, pretty soon with this, you know, AI tech explosion, we're going to see that it's going to get kind of out of hand really fast. So so I'm just leaving, you know, some of these phrases out here for your perusal, but this is an example that they use on their website, which I found interesting because I do remember Vijay Kumar. He's an amazing drone pioneer, swarm robotics, really a pioneer, and using drones to be able to build, you know, complex structures, 3D structures, etc. So, you know, what I found interesting is that with their preliminary data and with their AI engine, they're starting to see some pretty interesting patterns being elucidated of what that particular research article is all about. So real preliminary results, but I still think it's quite interesting that inertia is definitely one of the main components of that article and the walkaways. So just leaving it out there that there's tools out there that are coming out to help us make sense of all this AI tech explosion. So now I'm going to talk about the rise of deep learning. So why deep learning as a service? I think it's a great way to save money, to be honest with you. It's something that I considered heavily, do I want to be? And you know, we'll discuss, you know, kind of the more existential questions that you want to ask yourself. Do I want to be an AI company or not? Or do I just want to be a medical device company or whoever you are, and you're just generating big data? Do I really need that core competency in-house is the question. So the reason for not maybe building this team yourself, especially for a startup, and the considerations that I personally had is this data that I took from imed.ai. Now the website is being revamped right now, and full disclosure, I am an advisor for this startup. Mainly because I interface with them. It's a good friend of mine, and they help me with my deep learning pipeline and development. So you know, me being kind of like the business / entrepreneur, I started making sense of this with numbers. So this is kind of like a really rudimentary back of the envelope, but I think there's some truth to these numbers here. This is what I consider a typical minimalist AI team that's necessary even in a startup, is that you have your data management, hardware, software director, basically your super IT, which can manage, from, in my case, small hardware like basically little mini supercomputers, the NVIDIA TX1, if anybody knows, and then all the way, you know, that's managing basically AI at the edge. We're doing AI at the edge and also AI in the cloud, potentially, all the way through the whole gamut. And I'll talk about that, what that means. So truly full stack development. So you need a pretty exceptional person here. And then a research scientist 1 and a research scientist 2, but you know, actually this should be called application scientist. Somebody that's, you know, knows the tools out there, knows and knows how to use them, given a good, you know, data out there. So basically a supervised deep learning person, and then you have your PhD level research scientists that can go into the unsupervised realm or semi-supervised. So that takes just a whole nother level of expertise, right? So the main thing here is that this is your typical salaries. You know, we're throwing out numbers, but this I think is even low for a deep learning specialist. So anybody that's out there that's actually hardcore, you know, going into deep learning as a profession, you know, you're doing well. You're very much in demand, but on the other side of the coin is that if you're the entrepreneur that's trying to hire these people, it can get really costly really fast. You know, typical equity spreads. The point is that you have, you know, something on a 1 year time scale here. You have an amazing investment that you have to make in order to make a real, you know, solid AI team, at least at the beginnings of one, and significant dilution. And why are you doing this? You know, maybe, you know, you think you need that kind of expertise in house, but even if they're experts, I argue that, you know, you're going to have a ramp up phase for anybody that's dealing with your particular application, especially if you're in that unsupervised, semi-supervised range where you're really stepping outside of the norm in your particular application. So something to consider. You know, that's a lot of money to spend on a 1 year where you might just need a proof of concept, and then later, you know, once you find a further investment, and make this larger investment into the team. So minimal team composition, just a little bit more detail. The generalist futurist, I also tout that you have to have somebody that, you know, can be up there to see the general trends, what the customer needs, really focusing on optimizing for the customer always when you're selling something. Computer systems architect, general data workflow design. So there's a lot of words, just super IT dudette. Sorry for the California lingo here. But so the point is, this is a real exceptional person that can actually, you know, not just manage data, really thinking about the whole hardware stack as well. And then machine learning, like I said, research scientists, application scientists, then you have specialists in the field in data acquisitions. This is really important when you're talking about acquiring data. In my case, it's medical data. You're gonna have to talk to MDs, you're gonna have to talk to neuroscientists. There's a lot of other considerations to be able to get the best quality data possible, right? So our machine learning and our deep learning is only as good as the quality of our data. So maybe you want to save that money for the actual data acquisition, and I'll go into further detail later on here. So IBM's take. So IBM is now, you know, very much, you know, the inventor of the personal computer. They've been around forever. The interesting thing is that, you know, they really became a consultancy in the last, you know, 10, 20 years since they got out of the consumer hardware space a little bit. But now they're really hot on deep learning as a service. And this is a journal article that I recommend to reading. They have basically kind of a similar justification that I'm giving here for deep learning as a service. But I think they're missing one key component, which I think is a more hands-on component. They give you just here the kind of the typical, hey, if you have why would you build your own hardware and or use your own hardware when you can just leverage the cloud, the economics and the technical of the cloud? And that's what is happening in Google Cloud and Amazon. But I also argue that you know, where NVIDIA is starting to play a little bit more is that they're also worried about data acquisition at the edge, and I will discuss that more and what that means. So this is kind of the dynamics. So the deep learning research team dynamics. So you have your researchers. You also have your high performance computer or computing system. So you need somebody, they're the researchers, the computer systems background, like I said, your super IT person. And then you have data acquisition specialists. So be that, you know, a doctor or something gathering MRI data. So then you have that, and then right now, like I said, there's an emphasis on you know, supervised, because there's a ton of data, and it's kind of a blue ocean of opportunity using already existing data sets, and that's fine, that's great. But if you're really trying to innovate as an entrepreneur, it's, you know, you should be working on the biggest idea possible as an entrepreneur. You're in that 10 to 30% of novel algorithms that you have to develop. So that's where, you would think you'd have to, it's kind of counterintuitive. You think you'd have to come in and build it in-house. That makes more sense. But I would argue that the opposite. So you want to actually work alongside a partner is my strategy. And this is just my take, but the point is that I'm arguing for that because I just don't want people, to think that they might need a full in-house team unless you are a deep learning AI house, or that's what your core competency is going to be as a company. So this is what I found really interesting also. So the dynamic, it's very much like rapid prototyping in many things, digital fabrication, if you're building hardware. But in general, if you're rapid prototyping in deep learning, you have that design idea or hypothesis, and you have an experiment, and then you have a result. And then you immediately see how you're optimizing towards your end goal. And makes perfect sense. But the interesting thing is here's Andrew NG. Sorry, I don't know how to say his last name. But so here's Andrew, one of the grandfathers now of deep learning, saying that the optimal deep learning innovation cycle is driven by running experiments, preferably in less than 1 day time. So that was impactful for me because I did see that pipeline and you guys see it as well when you're playing on your laptops, doing your minced algorithms or your minced protocol. Point is, these experiments and I guess I don't know if it's the human condition or what. I've seen innovation that if it's longer than a few days cycle, then it's not progressing fast enough, honing in towards optimizing on a solution or a pattern. So again, to drill down, my personal experience is this company called imed.ai. It started as a medical image analysis company, and this is a guy that he's a good friend of mine, Cornell Shuttle. He's an amazing guy. He's a very multidisciplinary as well, the MD AI kind of computer science person. He developed a 3D CAT scan imaging engine, if you will. It basically grabs a bunch of 2D slices of the brain and makes a 3D representation and creates what's called voxels. And through that, he very much needed to develop some interesting algorithms to be able to do, first with machine learning. He was very early on with the machine learning to deep learning transition, and uses now deep learning to be able to do cancer identification. And what happened is that at some point, somewhere around 2013, 2014, he had some early successes in deep learning. And then a lot of people started approaching, hey, could you help me do that with my data set? And he started to do that. And he lo and behold, he had a couple contracts already, just, working for people and working with alongside people really to build these deep learning pipelines. And it turned out to be a whole business in and of itself. So I consider him, my first off example. Not only did I use him as for help, but also I also saw it firsthand of how he morphed into this deep learning as a service for medical imaging. So that's kind of his space that he plays this. That's his specialty, and now people are, he's getting well known in that regard. And it's I think he's on to his 5th project right now. So now diving kind of into another realm, which is kind of where is all this AI tech headed? And I think it's important to, and I find it entertaining just going into all this. But why is AI here, and where is it going? Is really important to understand. Especially if you're building a business around this stuff, and or a deep learning pipeline, as I call it. Is that you have to see kind of where the puck is headed, where all this is going. So a little bit of a background on myself and how I understand where this is all going. And I think everybody's seen this particular, maybe that's particular representation, but this is Moore's law. So we're looking at the transistor and how the concentration of the transistor has led to computation. The doubling or basically the exponential growth of computation per unit area on a CPU. So with the high density transistor hardware, we eventually led to this interesting cycle that I'm starting to see, and I find very interesting, is that you had software like computer-aided design that was developed. First there was Excel spreadsheets, etc., like with the first early IBM machines, and then it went out into the consumer hardware space in the 70s, 80s. And then you started seeing CAD, so a more sophisticated level of software where you can actually do computer-aided design. And that, I'm going to fast forward all the way to 90s, where we started seeing now something called the GPU. So the GPU is a very specialized piece of hardware to be able to manage the frame buffer of a screen and be able to do more complex things and refresh rates, etc., for graphics. So then eventually this led to designing better hardware, right? So we went from CPU to GPU. So now you have this specialization within your hardware. And eventually, 20, 30 years later, this GPU has advanced amazingly and made machine learning and AI possible. And that happened, circa 2009, as people are saying, 2009 to 2012, the big bang of deep learning, as they call it. And then now we're seeing machine learning and AI also helping new hardware, which is the TPU, which is now specialized hardware for deep learning. This is Google's advancement. And then eventually we're going to see a new level of software as well. So, I should say that this is called, from Singular University, this is a borrowed term on the accelerating returns. So this is the law of accelerating returns, as Ray Kurzweil says on Moore's law. So there's a lot of other exponential technologies spinning off of this exponential curve. And trying to just do that mental exercise is actually super useful to kind of, I think, get a good global understanding. So diving deeper, what's relevant to why AI is happening now, and where I think it's going to continue, is originally CPUs and GPUs, or computers in general, were used for computational flow thermal simulations. And that CPU GPU transition and playing with that arose some interesting, ancillary, what we call exponential techs out there. So you have your computer graphics and gaming, further consumerization of this hardware, and now you have CAD that not only you can do some rudimentary physics, now you can get super granular on this physics to where you're physics, you're modeling the photon, right? So this is ray tracing, example of ray tracing, or these other interesting graphics techniques. Well, what did that do is that gave rise to new hardware. So when people saw that the gaming industry was a thing, they started making GPUs that were better for OpenGL, for whatever graphics language that they needed for those gaming things, gaming ventures, I should say. And so we started seeing this spill out to all reaches of the planet, and people are starting playing with this stuff. In general, that stuff started feeding back into the scientific realm, and eventually, 2009, 2012 is when that point where NVIDIA got together with industry, like Google, and then academia, with the DeepMind project. They open sourced the GPU is what they did. And so what I'm going to dig deep of what the trend is here is we have the CPU that's actually not, it's based on kind of first in, first out principles, where it's kind of a serial data processor. And then you have the GPU, which is a highly parallelized graphics engine, but then now hacked, if you will, and turned into deep learning, like specialized math for deep learning processing engine. And now the TPU, which is now a hardware designed specifically for the tensor math, basically the deep learning math. So this is just a quick synopsis of what I think is a summary of what's going on here, is that when we tapped into the GPU, we had scalable recruitment of semi-specialized programmable hardware. And it was a hack at first, but NVIDIA saw, and everybody saw the opportunity, once they saw some results in 2009, and now are starting to gear that hardware towards deep learning. So what that led is to the digesting of big data and dividing data into bite-sized chunks or tensors. Depending on what you're doing, it's how many dimensions on that data set or that tensor. So moving on to where it's kind of the ultimate development of all this hardware is that now we have what's called the TPU, which is a tensor processing unit. This is the general trend of the GPU, actually, kind of starting to become a little bit more specialized in NVIDIA's take. This is NVIDIA's hardware. So just a comparison of the CPU, 3 teraflops, and it's measured in trillions of floating point operations per second. And then this is the first kind of deep learning workstation that was serious enough to be installed in a lab, not necessarily in the cloud. So this is Google's play on the Google Cloud Computing Engine, but it's just amazing. Now they've surpassed quite quickly the workstation with 1 unit of these this TPU, and it's 180 teraflops. So eventually leading to recruitment and getting something like 11.5 petaflops, which I just find amazing and interesting because of how close it is now approaching the human brain, so which is measured in exaflops, mind you. But I just think it's kind of fascinating where this is all headed. So we can say there is no stop in sight. There's no end. And so there is a use case both for the small stuff, so AI at the edge, and then you have the big stuff, the AI in the cloud. So what does that mean? AI at the edge is kind of where I play, when I'm trying to acquire data at the edge. I maybe don't want to send all data to the cloud to get processed. So it's also a lot faster. So for robotics, edge computing is really, this is your single board computer. Edge computing is really quite valuable in robotics because you don't have latency. That's really the big benefit there. So when I'm saying full stack machine learning workflow development, for me it became very obvious is that I need to kind of divide and conquer here. I can't be an expert in all of this stuff, and that's where I think anybody would agree, in particular in robotics. But where I'm actually taking sensor data at the edge and also have a mid storage, let's say right here, and then going all the way to the cloud. So they all have their different requirements, different specialties, and obviously I'm going to have to navigate all that. So in doing so, definitely want to delegate as much as possible to the experts. Okay, so just talking about is this right for your project or enterprise, and that's something going into just a very basic overview of what it takes to build a model, and how hard it is. It's when you go from scratch and you're really diving outside of the 70% supervised type realm and you go into the unsupervised realm, we're starting to talk about really complex data sets where you need that diverse group of people. So I leave this up here as just you have your typical numerical method problems where you can have underfitting, overfitting, and then there's a lot that can happen when you're trying to hone in on your optimization, and that's something that maybe you want to rely on an expert to do, and be that Excel.ai is creating experts as well. I think that's one of the things where networking and knowing people that have experience in certain realms or a certain dimensionality of your data set is really important. Where I like to emphasize, and I'm going to show you my example of why I think this is interesting, is that here you can see, like we said, there's the typical visual facial recognition type stuff, and then in the medical space you have kind of a bottleneck where you don't have access to a lot of this data. So you really need to have resources to dedicate yourself to getting the best data possible. And not to say that this is any more difficult than the other, but maybe access or many other things make it a little bit more difficult in the medical arena to be able to get the best quality data possible. So every situation is unique, and that's why you really, again, have to think about that from when you're building the whole pipeline. So this is a fun example. This is Lush Robotics, and this is my startup. We're kind of straddling between the service industry and robotics, and bringing robotics into the service industry. So Lush Robotics is a digitally manufactures drinks at the milliliter level. So this may be alcoholic, maybe not. Actually, would love to give alternate forms of drinks. But really what's going on here is that we're trying to hone in on your personal preference. And since we can actually adjust anywhere from 24 ingredients and make up to 200 different drinks with the robot that we have, it starts becoming pretty interesting. Basically a big data generation tool. And the neat thing is that with all those different inputs and outputs, you can start seeing patterns in this data. We want to see this real time and capture that data. So we wanted to basically approach the optimal drink for you. And eventually, we also thought maybe we can actually quantify your general happiness with that drink using EEG and other sensor technologies that are really kind of old. They've been around for 50, 60, 70 years, depending on where you put the line there. But now are becoming a whole new tool with this with deep learning. And this is just a quick example that I keep touching on with my talks, just because I find it interesting. But I've updated here with a new slide to show kind of a little bit more clear how the dimensionality of EEG data works. So we're using this OpenBCI headset. It's an open source EEG headset, which is actually 3D printed, and that's how they produce them. Really cool company, OpenBCI. I recommend them if you're into EEG. And so this is the main benefit of using convoluted neural networks. You're basically taking out a lot of pieces in this pipeline and just getting out to your output. So from very complex signal acquisition of the brain, there's basically electrical impulses on the surface of the skin. We're trying to define how the brain works. Not an easy thing to do, but we're making progress. This is just basically a 3D tensor how the data is organized. You can see that the frequency and time, right? All the frequency of the signal and time, and then the channels. These are the number of channels or the number of nodes that you're picking up. That turns out to be a 3D tensor. This is preliminary data of EEG and taste, so we can actually see, a signal. We gave about 300 or so impulses of taste. This is somebody's head. This is a bird's eye view, and we're starting to see a little pattern here. We can see, oh, interesting. Is that enjoyment? Is it not? And that's the perfect A/B testing. Is what we think, if we can get some good results in that direction. So that's kind of an example of that. And then where we're headed is to be able to actually use other sensors like fMRI to be able to complement this data. So this is where I'm saying, do we really want to be in-house specialists of deep learning, or do we want to be specialists of sensor acquisition or data acquisition? So there's a lot of things that need to happen for our particular use case. And I'm not saying this is right for every use case, but just telling you my story, and maybe it's similar, and you guys can take a good walk away there. So this is the UCSF neuroscience department that's basically using computer graphics to show and EEG to show somebody enjoying some music here. You can see the pathways of what they modeled as pathways of stimuli going through the brain. And now they call this the glass brain. So it's just a cool 3D representation of how complex and beautiful the brain is. And eventually, this is something that they did with years and years and years of work. And now, probably without deep learning, I believe, now they're going into the deep learning realm. And you can see that when they start coupling it with fMRI and EEG data, they're going to see just a whole nother level of fidelity and really learn how the brain works. It's kind of cool. Okay, so the conclusion. Sorry if I'm running a little long, but the conclusion here is, are you a deep learning AI company? You have to ask this question for yourself. I did it myself, and I said, hey, I probably don't want to, for this particular project, Lush Robotics, I don't want to be a deep learning company. I want to be a big data generation company and emphasize on the quality of data. And that's basically what I wanted to do. So then, so for me, deep learning as a service was a good option. And that's where I engaged in Mint.ai. Deep learning as a service is a good choice. If you see something already similar out there and somebody has a good product offering, a good API where you can just upload your data sets, which are already there for some common applications, then go for it. Just use it. But if you're starting to play in the space of innovating in the deep learning space, then you have to make that decision. Do I partner with a company or do I build that in-house? And I think that's the two different paths that you can take. And then just something that I always talk about is convergence is key for seizing the big opportunities. It's kind of my entrepreneurial go get them kind of attitude. And then if you are going to build your own team, make sure you consider all the costs and where you are headed and who you want to be. So in conclusion, that's it. And just a huge thank you to Laura and the amazing work she's doing at Excel.ai. I think it's awesome that she's engaging such a diverse background and preparing deep learning people for the future. All right, thank you very much.
Thank you, Carlo. We really appreciate you joining us and giving us this presentation. We do have some questions in the chat. I would like to open up the Q&A now for people that have been watching along. So I'll just go ahead and read these off, and I think I also sent you the chat link, but I'll read these off to you, and then feel free to answer them how you please. So the first question we have here is, what about Spark machine learning? Do you see Spark developing something equivalent for deep learning?
Spark, I'm not familiar with Spark actually, so I'm probably going to get a lot of questions that I'm not familiar with. The point is that I myself, the whole purpose of this talk is actually delegating a lot of this stuff. So I would love to hear what Spark is, and maybe I can give a little bit more input, to be honest with you.
So Spark specifically works with big data sets and large HDFS structures, right? So big data structures. So they're just like a scientific package for machine learning with really, really large data sets.
Oh, I see. Okay. Yeah. So for not to well, I mean, I can only imagine let's back up on that question. So in particular, his question or his or her question was what with Spark?
Yeah, do you see Spark developing something equivalent for deep learning, like maybe a deep learning as a service instead of basically their tool does machine learning for very large data sets? Right.
Sorry about that. Yeah, so it makes perfect sense. I think if they're specializing in the cloud and being able to manage these large data sets, then yes, I think it's called deep learning as a service, right? I'm coining that term like it's a new thing, but it's already existing. What I see in AWS, where you have the facial recognition, you have the object recognition with Google that I've been using for robotics, it's already there, and it's kind of like a coined term, but it's really just, hey, do you have a service out there that you can use that happens to do with deep learning? Now, for me, I wanted to expand it a little bit when we're talking about not just a software solution, but also the full stack development, which is basically the hardware considerations and the data acquisition. And that's what I'm calling kind of deep learning as a service, kind of the new deep learning as a service. because it requires human interaction. It's not just a spun up piece of software out there, because you need to literally refine. And that's the cool thing, is that, you know, we're not being replaced. We actually need to refine and hone in on that optimization. The human definitely has to be in the loop when we're trying to do big things still. So until that AI 2.0, where it's teaching itself in general AI, which I think we're far off, we need that full stack. So so yes, I think you can consider that a deep learning as a service already, is my answer.
Great, thank you. And then we have another question in the chat here from Timo Dank. He said he did not really understand why you think there is/should be a transition from supervised to unsupervised learning. He said maybe you can explain that again.
Right. So my whole thing is that, you know, my take on this, and I don't have to be an expert in this, and I'm consulted on this, is that supervised learning is something where you can grab existing data sets and make your own, make your hypothesis based on that, of where you want to go in your particular innovation. I think it's a case-by-case basis. So in my case, I can just speak about my case, is that when we're trying to kind of go out and discover a new metric, which is basically the enjoyment metric of a drink, let's say, that for me is going to necessitate a real-time assessment of large amounts of data. So we're trying to see is if we develop something at the edge in an unsupervised way to be able to get a filtering technique, if you will, for the big data being generated at the edge or at the consumer. And that way we can actually determine our labeling in real time. So we can't actually have a supervised method for that. So that's kind of like at the limits of where I really understand it. And that's actually something actively we're pursuing. And if somebody has any input, by all means, shoot me an email.
Great. And then let's see, Abdullah said, what about privacy of data? How is owning more data, how could that influence the balance of this market and even the whole world? Would deep learning as a service push us in this direction?
Right. Actually, you know, that's a very good question. I like to talk about the social implications, if I may, to kind of steer it in that direction. With any of this stuff, I think, you know, like the work that you're doing, Laura, with Excel.ai is an awesome conversation that we should democratize these technologies, so we don't have any one person controlling kind of like those data sets and or optimization algorithms. And I'm coming from the biotech world, and right now there's a huge controversy of, you know, there's 1 million genomes out there that have been sequenced, DNA sequenced already, and why don't we have access to that stuff? Well, I think, you know, there has to be an economic proposal there in that case. In particular, you just have to say, hey, big pharma, you know, it'd be good if you work on this with me, because I think there's a lot of innovation now happening, you know, in a democratized fashion. And I think it's going to continue with deep learning, especially with these open source tools and this hardware out there. And I think, for instance, Google understood it. Why did they open source TensorFlow? I think you have to ask yourself that question. I think because they themselves are also understanding that this is tremendously powerful technology that they will get better as soon as they throw it out into the crowd. And then also, I think in general, it's just a healthier ecosystem if you have input from all different places. That being said, deep learning as a service, like let's say IBM, for instance, that's, you know, really taking the reins on being a deep learning as a service institution, they're going to benefit tremendously, and vice versa. I think about hearing about new projects. Data privacy for me, you know, like that's one of those things that I think we should always be careful with, especially when I'm talking about patient data. I have to be careful with that. you have to take the normal precautions. I think there's nothing different. All data is something that has to stay secure, especially in the medical field. But I don't think that should stop anybody playing in this space. And I think, we have to also see that when we do have these huge innovations in technology where we have a lot of data that's going to be quite powerful, we're hoping that other technologies around this will help us manage this. So I hope that answers the question. But I think that's a whole other discussion of, data security and stuff. And
definitely.
I'll leave it to somebody else.
Yes, and then we have another viewer, Krishnap, that asked, can you elaborate more on edge computing? Does this involve data lakes or some other pattern?
Data links. Okay, I wish you could define data links, but yeah. So edge computing, I can talk strongly about that one. So so edge computing, so single board computers, Raspberry Pi, for instance. These are little processing engines that are basically really fast computers for $35. And what they can do is actually using video. Using little video camera on these little single board computers, you can get basically a low power data acquisition tool. So for instance, if you're, there's a neat piece of software that's out there. It's called Mobileye. It's literally a whole operating system on top of a Raspberry Pi, and it's monitoring a video. And every time it's using machine vision to be able to turn on the video when you want, and turn the video when you don't want. And that way you don't fill up your little SD card, which is the hard drive on this thing. The neat thing is that you can actually now put a little TensorFlow on this Raspberry Pi. And we're seeing this in the little self-driving car phenomenon. We're seeing remote control cars being driven by these Raspberry Pi things, the Donkey Car project, which I'm involved in. The neat thing, though, is that you can come in there and actually do a little deep learning filter to be able to say, hey, you know what? Not all motion is what I'm worried about. I'm worried about a human motion. If I want to detect if there's a human there versus if there's a squirrel or a cat or whatever. And that's where it gets pretty interesting, is when you can start seeing deep learning deployed at the edge to be able to discern when you actually record and when you don't. So that's kind of the example that I like to give when I'm talking about deep learning at the edge. And that's basically it's really powerful because it cleans up your data a priori before you start training on that data.
And there's another question that also is relevant to edge computing. Antonio has asked, do you believe edge computing, like embedded systems, will they involve recognition? Or no, maybe this question isn't fully written out properly. Do you believe edge computing, like embedded systems, that do evolve recognition are possible without specific integrated GPUs? Oh, sorry, it was voice recognition. Okay, let me repeat that one more time. Do you believe edge computing, like embedded systems that do voice recognition, are possible without specific integrated GPUs?
Without specific integrated GPUs, I don't think so. I mean, I think voice recognition is not so dimensional. It's not so heavy. So the point is I think it depends on the pattern that you're looking for. You can get pretty complex, but yeah, absolutely. Edge computing can do vision, like I just said. So that's multidimensional, highly multidimensional, possibly when you have 10 to 30 frames per second, anywhere in that realm at 800 by 600, let's say. Well, really, that's maybe too heavy for Raspberry Pi or something. But yeah, I think I haven't done that, but I would guess yes. If the images, if you can do it with imaging, you can do it with that. Now, I should put a caveat. There's always a latency. So it just depends on your use case. I mean, if it has to be like, even Alexa has a latency, and they have some of the most sophisticated hardware at the edge and software in the cloud to be able to manage that real-time interaction. So it just depends on your requirements. And actually, another perfect use case here is to really know what the heck what problem you're trying to solve. is really where you should start. Then you start throwing the technology out there. Yeah.
Definitely. And then last question, is it possible to get the slides afterwards?
Sure. Yeah. Absolutely. I think it's already recorded, right?
Yes, this is recorded. Yep.
Okay. Well, I mean, if you want the slides as well, no problem. I think I should probably give some credit here and there. Other than that, I'll clean them up. If somebody just emails me, and I can shoot them over to you. So just shoot an email at carlos@lishrobotics.com.
Okay, wonderful. Well, thank you very much again, Carlos, for the awesome presentation, super in-depth and exciting for all of our viewers. And thank you for everyone who tuned in and joined us. At the beginning of the chat thread, I did share a link to our new member survey. So if you'd like to be a member of Excel AI, we have several different channels online. Obviously, we have our YouTube channel. We have our AI and Deep Learning Enthusiast Meetup group where we meet both online and in person. We have our Facebook, Twitter, Instagram, everything. So if you'd like to be part of our, our group and our community, please join and contribute and ask questions and continue the learning along with us. We are trying to build a more diverse and inclusive AI community. So thanks everyone for joining, and we'll be signing off till next time.
Thank you, Laura.
Yes, thank you.